Cancer is a major cause of death worldwide, but infectious diseases kill 20% more people. And the threat of a new outbreak, perhaps the next plague, is only rising.
The level of interconnectivity, whether it be the movement of animals or movement of humans by planes, from the perspective of a virus, we're one single population. We live at this moment in history where we're going to have more and more pandemics. It's just the nature of the way that our species is.
When the SARS epidemic of 2003 jumped from China to Canada, public health experts were blindsided and worried.
If it hadn't been Toronto, it could have been anywhere. And I think that's the ultimate fear we look at with pandemics.
The Chinese government responded to the outbreak by beefing up their command post for epidemic surveillance at their Center for Disease Control.
What you see is truly state-of-the-art ability for a large country, 1.3 billion people dispersed over a huge geographic area, to collect real-time data on over 30 infectious diseases. The Chinese track that data, aggregate it, report it, and then deal with it at a political level in any way that's necessary for the Chinese government to respond to an infectious disease outbreak.
China's disease surveillance system is arguably the best in the world. Around the clock, thousands of hospitals and clinics report large amounts of patient information, but the approach is low-tech, diagnoses and symptoms. The new biology can take disease surveillance to the next level by focusing on places most likely to become the source of a new pandemic, the hot zones of the world.
We do know certain things about pandemics and how they're born. We know that certain host species out there are more important than others with regards to seeding us with new agents. Bats, non-human primates. We know that there are certain sorts of behaviors which are very, very important for cross-species transmission. Hunters, people who have contact with a vast range of wild animals and who have contact with all the various viruses that exist within these animals. And all of those represent opportunities for the transmission of these viruses into humans. But most of the viruses out there that have the potential to spread in humans we're not aware of.
Working in hotspots, virologist Nathan Wolfe takes blood from humans and prey animals. But these are only partially sequenced, and that's back in the US, after a significant delay.
The idea that you could take a drop of blood and find out all of the genetic information in that drop of blood, get a sense of all of the organisms, all of the viruses, all of the microbes that exist within that drop of blood, that's something which we have really not attained, but which would be incredibly important for our field. And the moment that we get it, it'll change the way that we do this kind of work.
Until all potential pandemics can be caught in the first sick patient, the next most important use of the new biology is to slow the spread of an outbreak. And that means early detection of a pathogen's spread. In a pilot project in a large American city, raw data is coming from raw sewage. Researchers collect regular samples from a number of plants. Contamination from sewage, it turns out, is responsible for many outbreaks, including SARS. Samples can now be directly sequenced to detect known and unknown pathogens.
Can we real-time monitor those environments for these different things that make you sick? Things like single-molecule real-time sequencing, able to get whole genomes of pathogens sequenced. From collection of the sample, to sequencing of the sample, to getting the data. Well, what's in those samples? Do I see influenza? Do I see noroviruses or other more severe viruses that would cause public health concern?
Now imagine using sequencing data with fine-grained geography and displaying the results on a new kind of map, a disease weather map. You might see a flu outbreak starting near an airport. You could zoom in on your neighborhood restaurants to see where you shouldn't go to dinner tonight. You also might even get a forecast. Cool colors signify a low rate of infection. Warmer colors show harder hit areas. And people who drive can spread the outbreak like a wildfire. If it's H1N1, you could have Tamiflu shipped in advance, or travel could be limited to slow the spread. Actionable results will be the hallmark of the new biology.